As you've started to get some experience with these alternative ideas for how to represent a list, like a node that can store some data and can have some information that points you to the next thing, then I want you to think about practically how you would actually access particular things in that list. If you have a head and you have a tail variable, and you don't get the free, easy indexing like you're used to in an array, then how do you actually get to data inside of that list? And so what I want you to think about is a statement or a line of code that you could use to print the value 9, but it has to come from the node in this list. So up front, you don't know what its value is, but you know you want to get that node. How could you refer to that node if all you have access to at the start is something that indicates the head and points you to that node, and something that indicates the tail? So whether you can think of it in code or you can think of it in words, how would you describe that particular node and get its value? And how could you then use that to print it out? So pause a moment and think about at least a description or possibly some code or pseudocode that you could use to access that third node there and print out its value. Pause the video and think about that for a moment. Okay, so let's walk a little through some of the things that we have here. Well, we have head, and head points us to a node. So if head is some variable that points us to this specific node, then we could say head.data, and that would be 5. So head.data would be 5 because it's accessing that node at the head and it's getting its data. This is like saying array at index 0 and getting that data. So if from there, and by the way, you'll notice I've indicated the nexts with just an N so that I could write this easily, but I'll use next when I type it as code. If from there I wanted to get to the node that has 7, I could say head.next. And then I could ask for the data from that node that I've found by going next. And so head.next.data would be 7. And so now you can perhaps see where I'm going with this, that head.next.next, because if I go to that node with 7, yes, it has data that is 7, but it also has a next, and that next is set to be this node. And so head.next.next puts me at this node with the 9, and then I can just ask for its data. And now I've got access to the 9. And if I wanted to get to the 11, then I could say head.next.next.data, though that is also the tail. So I could try tail.data for that last one if I knew it was the last one. I can't go backwards in this design because these only have a next. You'll see designs that allow you to go back and forth in terms of a next and a previous, but for this design that I've shown here, we only have the next. So the way to get to that 9 is I know I can start from the head, I can ask for its next, and I can ask for the next again, and that gets me to the third node. And so if I knew it was the third node, that's the way I could get it. You'll also notice that I can keep going next until I hit the tail. Once I hit the tail, often the design will be that its next is just a null. And so we do often have to be careful about trying to access the next too much. So you'll see things where we say, while the node is not equal to null, or while the node's next is not equal to null, or different things like that to prevent us from sort of going off the edge of the world here. because unlike an array, we don't get a nice index that indicates the end for us of our thing. We've got head and we've got tail, and tail points us onward to null. So there's this neat way of thinking that I hope will open up for you as you work a little more with lists, and particularly linked lists. So a linked list is a list in which our nodes point to another node directly. They have a next and or a previous that points you to another node. There's a linkage between them through those variables, because what we've sort of pulled out from the start of this course onward is our concept of a variable and how data is stored. And previously, we often sort of thought of variables as these magical things. They hold a value and that's all they do. And that's true for primitives. But for non-primitive types, like a node, or like a string, or a scanner, or lots of other types that are non-primitive, our variables are actually references. And so when I ask for head, that's a reference to this node that's here. It's pointing to that whole node object somewhere in memory. And when that node has a variable called next that points to a different node, it's a reference. It's a reference to that object out in memory. And so what we're doing with that link, the link between our nodes in a linked list, is the reference that one node's variable of next makes to another node. And we can either add references on. For instance, if I added another node as the next after my tail, and then updated my tail to point to that new node, I've just extended my list. And I've done that almost for free. And likewise, I can add a new node as the head, and I can point that node to the old head, and I've added a new node for free. It's like that scarf we looked at before, where I can add things very easily onto the ends here. And I can still, if I want to, access things toward the middle by going from the head to the next, to the next, to the next, stepping through, using those references to guide me through memory. Wherever the objects exist, they don't have to exist in one solid chunk like an array does. And we lose some things. We lose the ability to quickly index and find the thing at index 4. By just a few simple multiplications. We may end up having to step through several different nodes to get there. And by the time it's index 4 million, that can be very slow. So it does lose some capabilities. It does have some downsides to it. But what we gain is this idea of being able to reference new things and to tag them on at the head or at the tail simply by creating a new object in memory and then changing some references so that they are linked together by those references there. One thing that you'll see happen quite often is that we might start off some current tracker of a node, because even this variable that I'm starting to set up here is just going to be a reference. And so this current that I've set up here is just going to create a new way to reference to a node in here. And so I might start current off at the head, and then often if I need to step through a linked list, I'll do something like this. While current is not null, then I'll do whatever I need to do at that node. Say I was adding 1 to every node through here. Well, I could say data plus equals 1 or something like that. And then the trick is I just say current equals current.next, and that will step it forward through the list all the way here, potentially, until the end. So I will go no longer does current point here. It goes and it follows the next. So it looks where it is currently. It looks at the next, and it follows over. And then it's going to do the same thing when that loop returns around again. It's going to say, okay, here's where I point, and here is the next of that. And so I will set myself equal, which we know for object types means change my reference. I will change my reference on cur to point here now. And then I follow that reference when I'm asked to do cur equals current.next. Again, I follow my reference. This is cur. Cur is a reference to the node with 9. And then I look at the next again, and I say, okay, change my reference to be where that next points. So we'll do it again. And then we'll even do it one more time where we're here at the 11. We follow current equals. Well, what should it equal? It should equal current.next. So I follow current. It points here. Next points out to that null. And so I'm going to then have a reference out to that null. You can reference null. That's what setting a variable equal to null really does. And then the loop will see, oh, current is equal to null, and it will finally exit down here and it will be done. This is a structure that it would do well for you to really, really work into your mind, write down in places you'll see it, practice it over and over, because you're going to have to step through linked lists quite often. And you want to use this concept, not manually going head.next, things like that, because you won't be able to program that in to automatically go out to, say, all the way through the list or things like that. You want to be able to keep some reference to where you are. And again, that's all variables are when they're an object type, is they're just references. Where you are at the start is probably the head. You should set it to be the head. And then when you want to step through, you just set current to its own next, and that will jump it forward to the next and follow again to the next and follow again to the next and so on. This structure is something that you will use over and over again as we work through these linked list concepts, and hopefully you'll start to make sure that it's a very solid concept for you, these nexts and these references, as you look at models E and F from the list activity.